By 1944, Field Marshal Erwin Rommel had turned the coast of France into a fortress. The Atlantic Wall was not just a propaganda slogan, it was a masterpiece of defensive engineering. Rommel, the Desert Fox, applied his engineer's mind to the problem of stopping an invasion. He analyzed the tides. He analyzed the beaches. He concluded that the Allies would have to land at high tide to minimize the time their infantry spent exposed on the sand. So, he built his defenses to kill them at the water's edge. He installed millions of mines. He planted Rommel's asparagus, logs tipped with explosives to tear the bottoms out of landing craft. He welded massive steel girders into Czech hedgehogs to rip the tracks off tanks. But his entire defensive strategy relied on one fundamental assumption regarding enemy armor. He believed that tanks needed ports. Rommel and the German High Command knew that a modern tank weighs 30 to 40 tons. You cannot simply drive a 30-ton vehicle off a boat into deep water. It sinks like a stone. Therefore, the Germans reasoned, the Allies would have to capture a major port, like Cherbourg or Le Havre, to offload their heavy armor. Or, they would have to use massive, slow-landing ship tanks, LSDs, that had to beach themselves directly on the sand. These LSDs were huge targets. Rommel placed his heavy anti-tank guns, the 75mm and 88mm cannons, in concrete bunkers specifically to destroy these large ships before they could lower their ramps. The German logic was sound. It was based on physics. Steel does not float. So, while they feared the Allied infantry, they were confident that for the first crucial hours of the invasion, the longest day, the Allied soldiers would be alone. They would be light infantry, exposed on the beach, with no heavy fire support. The German panzers, held in reserve inland, would then sweep down and crush the beachhead before the Allies could bring their own tanks ashore. It was a mathematically precise plan. The German engineers laughed at the idea of amphibious tanks. They had experimented with snorkeling tanks, the Torchpanzer, for the invasion of England in 1940, but those walked on the bottom of the river. They didn't swim. The idea of a tank fighting on the surface of the ocean was dismissed as science fiction. They believed the English Channel was too rough, the tanks too heavy, and the engineering too complex. This skepticism became a blind spot. They spent millions of Reichsmarks pouring concrete to stop ships, never imagining that the enemy was building a tank that was part ship. Rommel looked at the sea and saw a barrier. He didn't realize that the Allies were looking at the same sea and seeing a highway for their armor. The man tasked with solving that impossible problem of beach assault was Major General Percy Hobart. Hobart was a British eccentric. A pioneer of armored warfare in the 1930s, he had been forced into retirement because his ideas were too radical for the conservative British Army. At the start of the war, he was actually a corporal in the Home Guard, preparing to defend his local village with a pike. But Winston Churchill, who loved mavericks, brought him back. Churchill told him, "I want you to build a division of monsters." Hobart was given command of the 79th Armored Division. His mission was to create specialized tanks to breach the Atlantic Wall. These became known as Hobart's Funnies. He built the Crab, a Sherman tank with a spinning chain flail to beat a path through minefields. He built the Crocodile, a flamethrower tank to burn troops out of bunkers. He built the Bobbin, a tank that laid its own carpet road over soft sand. But the most important and most secret of all the funnies was the duplex drive, DD, tank. The problem was simple: infantry on D-Day would be slaughtered if they didn't have immediate tank support in the first 5 minutes. They couldn't wait for the big landing ships. The big ships were slow and vulnerable. They needed a tank that could launch miles out at sea, swim in under its own power, and arrive on the beach with the first wave of infantry. It sounded insane. When Hobart proposed the idea, many Allied commanders laughed, just like the Germans. "You want to make a 33-ton Sherman tank float?" But Hobart was undeterred. He looked at the work of a Hungarian-born engineer named Nicholas Straussler. Straussler had a theory. You didn't need to make the tank lighter. You just needed to displace enough water to counteract the weight. Archimedes' principle. If you could increase the volume of the tank without increasing its weight, it would float. The solution wasn't more steel. It was canvas. Hobart ordered his engineers to wrap the Sherman tank in a boat. It was a solution that looked ridiculous, fragile, and terrifyingly dangerous. But it was the only hope the infantry had. The design of the duplex drive Sherman was a triumph of desperation over aesthetics. It looked like a bathtub with a gun. The core was a standard M for Sherman medium tank. Welded to the hull was a waterproof canvas screen. When collapsed, the screen looked like a folded accordion sitting on the tank's fenders. The tank looked normal, and the gun could fire freely. But when the tank was ready to launch, compressed air bottles inflated rubber tubes inside the canvas. The screen rose up, creating a waterproof wall around the entire tank, extending several feet above the turret. This trapped a massive volume of air, providing the buoyancy needed to keep the 33-ton monster afloat. But floating wasn't enough. It had to move. This is where the name duplex drive came from. The tank had two drive systems. One was the standard engine driving the tracks for land travel. The other was a pair of small propellers at the rear of the tank, connected to the engine by a gear system. When in the water, the driver engaged the propellers. The tank became a boat, capable of moving at about 4 knots. The driver couldn't see anything. He was deep underwater, looking through a periscope, or usually, taking orders from the commander. The commander stood on a small platform at the back of the turret, his head just poking over the top of the canvas screen. He steered the tank using a tiller that controlled the propellers. It was a terrifying contraption. The freeboard, the distance between the water level and the top of the canvas screen, was only about 3 feet. If a wave broke over the screen, the tank would flood. If a wave collapsed the canvas struts, the tank would sink instantly. There was no reserve buoyancy. It was a heavy rock held up by a piece of cloth. The crews who were assigned to these tanks were horrified when they first saw them. They were tankers, not sailors. They trusted armor plate, not rubberized canvas. They called them floating coffins. But as they trained, they realized the genius of the design. When the tank hit the beach, the driver would disengage the propellers and engage the tracks. The tank would drive out of the surf. Then, in a matter of seconds, the crew would release the air pressure. The canvas screen would collapse instantly. And suddenly, what looked like a harmless boat would reveal itself to be a fully armed M for Sherman tank, ready to open fire on the stunned German defenders. It was the ultimate surprise attack. a weapon that transformed from a boat into a tank in the blink of an eye. But first, they had to survive the swim. The development of the DD tank was top secret. The training took place at Slapton Sands in Devon, England, a beach chosen because it resembled the Normandy coast. The secrecy was paranoid. Military police guarded the perimeter. Locals were evacuated. The tanks were codenamed Donald Ducks, DDS. For the crews, the training was a mixture of boredom and sheer terror. They had to learn to navigate a tank in the ocean. They learned to seal the hull with waterproof grease. They learned to erect the screen. But mostly, they practiced escaping. They knew that if the screen failed, a 33-ton tank sinks to the bottom in seconds. Every crew member was issued a Davis Submerged Escape Apparatus, DSEA, an early form of rebreather used by submariners. They practiced dunking drills, where they were submerged in mock-up hulls and had to escape in the dark underwater. The danger was real. During Exercise Tiger, a live-fire rehearsal for D-Day, German E-boats, fast torpedo boats, attacked the convoy. Several LSDs were sunk. Hundreds of men died. But even without enemy fire, the DD tanks were deadly. In one training accident, a DD tank launched in rough weather. The waves tore the screen. The tank vanished. The crew drowned. Panic spread among the secret battalions. Was this weapon viable? Or was it a death trap? General Eisenhower watched the trials closely. He was a pragmatist. He saw the risks. But he also saw the potential. He knew that the Atlantic Wall was formidable. He knew that the German bunkers were impervious to light infantry weapons. If the infantry landed alone, they would be pinned down and massacred. He needed heavy guns on the beach at H-hour, the very first minute of the attack. The landing craft tank, LCT, could bring tanks in, but they had to lower a ramp on the wet sand, making them a stationary target for German anti-tank guns. The DD tanks offered a solution. They presented a tiny target in the water, just the canvas screen. They were hard to hit. And they could launch miles out, swarming the beach from unexpected directions. Eisenhower made the gamble. He ordered that DD tanks would lead the assault on all 5 beaches: Utah, Omaha, Gold, Juneau, and Sword. He was betting the success of the invasion on a canvas screen. The German spies never discovered the secret. They saw the massive tanks in England, but they never saw them float. They remained confident in their logic: tanks don't swim. They were about to be proven wrong on the most important morning of the 20th century. June 5, 1944. Southwick House, England. The Supreme Commander, General Dwight D. Eisenhower, sat in a room thick with smoke and tension. Outside, a gale was blowing. The English Channel, usually a barrier, was now a churning cauldron of grey waves and white caps. This was the worst June storm in 20 years. The invasion had already been postponed once. Eisenhower had to make a decision. If he waited, the moon and tide conditions wouldn't be right for another 2 weeks. The secret of D-Day might leak. If he went, he risked the lives of 150,000 men in a storm. But for the crews of the DD tanks, the weather wasn't just a risk, it was a death sentence. The canvas screens of the duplex drive Shermans were designed for Sea State 3 waves up to 3 feet high. The reports from the channel showed waves of 5 to 6 feet. The physics were unforgiving. If a 6-foot wave hit a 3-foot screen, the tank swamped. Eisenhower listened to his meteorologist, Group Captain Stagg, who predicted a brief window of calmer weather for the morning of June 6. It wasn't perfect. It was barely acceptable. "Okay," Eisenhower said softly. "We'll go." The Armada set sail. On board the landing craft tank, LCT, ships, the DD tank crews were miserable. They were seasick, vomiting into buckets or onto the steel decks. They checked and rechecked the air pressure in the rubber tubes of their screens. They greased the joints. They prayed. The orders given to the LCT commanders were flexible. They were told to launch the tanks 5,000 yards, about 3 miles, from the beach. But there was a caveat: if conditions are too rough, land them directly on the beach. This decision, to launch or not to launch, was left to the captains on the spot. As dawn approached on June 6, the sea was still rough. Off the British and Canadian beaches, Gold, Juno, Sword, and the American Utah beach, the commanders looked at the waves and hesitated. They knew the tolerances of the DD tanks. They knew they were pushing the limits. But off Omaha Beach, the most heavily defended sector, the decision was made to launch. The LCT captains lowered the ramps into the heaving swells. The tank commanders looked out at the distant, foggy coastline of France. It looked miles away. It was miles away. They were about to drive 30-ton steel boxes into a sea that was angry enough to sink a destroyer. Eisenhower's gamble was a strategic necessity. But for the men of the 741st Tank Battalion off Omaha, it was about to become a tragedy. The disaster at Omaha Beach began 3 miles offshore. The LCTs carrying the 741st Tank Battalion lowered their ramps. The waves were running high, 4 to 6 feet. Choppy. Unpredictable. The first tank rolled down the ramp. Launch. It hit the water. The canvas screen held for a moment. But the tank was instantly fighting a losing battle. The DD Sherman was top-heavy. In the rough water, it wallowed. The commanders tried to steer toward the church steeple at Ville-sur-Mer, their landmark. But to do that, they had to turn broadside to the waves. This was fatal. A wave would crash over the side of the canvas screen. The struts would buckle under the weight of the water. The canvas would collapse. And then, gravity took over. A 33-ton tank does not sink slowly. It drops like a stone. One by one, the tanks of the 741st vanished. Commanders screamed orders over the radio that were cut off by gurgling water. Crews inflated their daring lungs and scrambled out of the turrets as the freezing water rushed in. Many didn't make it. They were dragged down by the suction or entangled in the gear. Out of 32 DD tanks launched for the eastern sector of Omaha Beach, 27 sank. Most of them sank within minutes of launching. They are still there today, sitting on the bottom of the English Channel, their guns pointing toward France. Only 2 tanks made it to the beach by swimming. 3 others were landed directly by LCTs whose captains saw the disaster and refused to launch. The infantry, coming in the waves behind them, watched in horror. They were expecting heavy armor support. They were expecting the tanks to be blasting the bunkers. Instead, they saw nothing but the sea. When the infantry hit the beach at Omaha, they were alone. The German gunners in the bunkers couldn't believe their luck. They had expected tanks. They saw only soft targets. They opened fire with machine guns and mortars. The slaughter was horrific. Without the tanks to suppress the pillboxes, the American infantry was pinned down at the water's edge for hours. The failure of the DD tanks at Omaha was not a failure of the concept, it was a failure of judgment. They were launched too far out in seas that were too rough. It was a tragic confirmation of the German engineers' logic: tanks don't swim in storms. But while the tragedy at Omaha was unfolding, a very different story was happening a few miles down the coast. At Sword Beach and Juno Beach, the British and Canadian commanders looked at the same storm and made a different call. They realized the waves were too high for a long-distance swim. They ordered the LCTs to move closer. Instead of launching at 5,000 yards, they launched at 3,000 yards, or even 1,000 yards. Some captains drove their LCTs almost onto the sandbars before dropping the ramps. The DD tanks splashed into the water. Because the distance was shorter, they spent less time exposed to the waves. They bobbed in the surf, looking like strange, canvas-covered blobs. Inside the German bunkers, the sentries were scanning the horizon. They saw the landing craft. They prepared their anti-tank guns to hit the heavy ships. But they ignored the small, low-profile shapes in the water. They looked like small boats. Maybe supply launches. Not a threat. Then, the boats hit the sand. The tracks bit into the beach. The engines roared. The canvas screens dropped. Suddenly, 30 tons of British armor was sitting on the beach, directly in front of the German bunkers. The shock was absolute. A German gunner on Gold Beach later recounted, "We were waiting for the ships. Then, suddenly, there were tanks. They just rose out of the sea." The surprise was total. The DD tanks opened fire immediately. Their 75mm guns blasted the embrasures of the concrete pillboxes at point-blank range. They destroyed the machine gun nests that were tearing up the infantry. On Juno Beach, the Canadian DD tanks arrived moments before the infantry. They suppressed the German defenses so effectively that the Canadian infantry was able to move off the beach and inland within an hour. On Sword Beach, the British DD tanks lead the assault. They provided a mobile shield for the commandos. The difference between Omaha, where the tanks sank, and the other beaches, where they arrived, was stark. Where the DD tanks failed, there was a bloodbath. Where the DD tanks succeeded, the Atlantic Wall was breached in minutes. The floating coffins had worked. They had delivered heavy firepower to the decisive point at the decisive moment. Rommel's calculation, that the Allies would have no armor in the first hour, was shattered. He had built a wall to stop ships. He hadn't built a wall to stop swimming tanks. The German defenders found themselves outgunned and overwhelmed by a weapon they had dismissed as a joke. To understand why the DD Sherman was such a technological marvel and terror, you have to look under the hood, or rather, under the skirt. The modification was ingeniously simple yet complex in execution. The standard Sherman engine, either a radial aircraft engine or a multibank Chrysler engine, drove the tracks via a drive shaft running to the front of the tank. For the DD, the British engineers added a power takeoff (PTO) at the rear. This diverted engine power to two propellers located at the back of the hull. The propellers were steerable. The commander, standing on his platform, could turn them left or right to steer the tank in the water. The canvas screen was the critical component. It was made of waterproofed canvas supported by a metal frame and rubber air pillars. It was raised by compressed air bottles. It took about 15 minutes to erect and inflate. But dropping it? That had to be instant. The screen was held up by hydraulic struts. When the tank hit the beach, the commander pulled a lever. The air escaped. The hydraulics released. The screen collapsed flat onto the fenders in about 3 seconds. This instant transformation was key. 1 second, it's a fragile boat. The next, it's a tank with a fully rotating turret and a coaxial machine gun. But the margin for error was tiny. The tank had a freeboard of only 9 inches to 3 feet, depending on the load. This meant that if the tank sat too low in the water, or if a wave was too high, water would pour over the top of the screen. Once water got inside the bathtub, the tank lost buoyancy. There were no bilge pumps powerful enough to save it. It was a binary system. It either floated perfectly, or it sank like a rock. The crews had to be incredibly disciplined. They had to balance the load perfectly. If they loaded too much ammunition, they sank. If the infantry rode on the back, they sank. They also had to maintain a perfect speed. Too fast, and the bow wave would wash over the screen. Too slow, and the current would sweep them away. It was a delicate balancing act performed in the middle of a war zone. The Germans mocked the idea because they looked at the safety margins. "This is unsafe," a German engineer would say. "It violates safety protocols." And they were right. It was unsafe. But the Allies realized that in war, unsafe is acceptable if it provides a tactical surprise. They traded safety for shock. And on the morning of June 6, that trade paid off. The mechanics of the swimming tank were a triumph of can-do improvisation over rigid perfectionism. It was an ugly, dangerous, jury-rigged solution. And it was exactly what was needed to crack Hitler's fortress Europe. Once the canvas screens dropped on the sand, the DD Sherman underwent an instant transformation. One moment, it was a fragile, bobbing target. The next, it was a 30-ton killing machine. For the infantry huddling on the beach, pinned down by machine gun fire, the arrival of the tanks was a miracle. A concrete pillbox is immune to rifle fire. It is immune to grenades unless you can get right up to the slit. Even bazookas often bounced off the thick reinforced concrete. But a 75 mm high explosive shell from a Sherman tank changes the equation. On Gold, Juno, and Sword beaches, the DD tanks went to work immediately. They didn't charge inland wildly. They acted as mobile pillboxes. They sat in the surf, hull down, and engaged the German strongpoints one by one. The German gunners in the bunkers were terrified. They were used to shooting at flesh. Now, they were staring down the barrel of a cannon at 200 yards. The noise was deafening. A 75mm shell hitting a bunker doesn't always penetrate, but the concussion creates spalling, chunks of concrete flying off the inside walls, killing or wounding the crew. Or, the tank would fire a shell directly through the firing slit, vaporizing the machine gun team inside. The psychological impact was immense. The German defensive doctrine relied on the impenetrable zone of the beach. Once that zone was breached by heavy armor, the defense crumbled. The DD tanks also provided physical cover. Infantrymen formed up behind the steel hulls of the Shermans. They used the tanks as moving shields to advance up the beach. Walking the dog, they called it. The tank moved forward, suppressing the enemy. The infantry followed in its wake, tossing grenades into the trenches. It was the ultimate expression of combined arms warfare. Without the tanks, the infantry would have been slaughtered, as they were at Omaha where the tanks sank. With the tanks, the infantry became hunters. The German fortifications, built over 4 years with millions of tons of concrete, were systematically dismantled in 4 hours by the guns of the swimming tanks. Rommel had bet everything on stopping the Allies at the water's edge. But the water's edge was exactly where the DD tanks were deadliest. While Omaha was a graveyard for the DD tanks, Utah Beach was their proving ground. Here, the launch went almost perfectly. The 70th Tank Battalion launched 28 DD tanks into the sea about 3,000 yards out. The sea was slightly calmer here, protected by the Cotentin Peninsula. But more importantly, the American commanders had learned from the drills. They launched closer to the shore. They managed their speed. All 28 tanks made it to the beach. Wait, actually, for were lost when their LCT hit a mine and sank before launching. But every tank that launched made it to shore. They arrived almost exactly at H hour, alongside the first wave of infantry. The result was a textbook assault. The German defenses at Utah were lighter than at Omaha, but they were still formidable. However, they stood no chance against 24 tanks arriving simultaneously. The DD Shermans dropped their screens and immediately began suppressing the German strongpoints. They blasted the seawall. They destroyed the 88mm gun positions. Casualties at Utah Beach were astonishingly low compared to Omaha. The U.S. 4th Infantry Division lost fewer than 200 men. At Omaha, the casualties were over 2,000. Why? Because the tanks were there. General Teddy Roosevelt Jr., landing with the first wave, famously walked the beach with a cane, directing traffic. He could do that because the tanks had cleared the way. The tanks at Utah didn't just secure the beach, they pushed inland. They linked up with the 101st and 82nd Airborne paratroopers who had dropped the night before. They secured the causeways across the flooded fields behind the beach. The success at Utah proved that the DD concept was sound. When operated correctly, in acceptable conditions, it was a war-winning weapon. It validated General Eisenhower's gamble. If the tanks at Omaha had survived like they did at Utah, the longest day might have been a lot shorter and a lot less bloody. The tragedy of Omaha overshadows the triumph of Utah, but for the military historians, Utah is the proof that the Donald Ducks were not a joke. They were the key to the door of France. The German plan for D-Day relied on a massive counterattack. Rommel knew that once the Allies were ashore, they would be weak. He held the 21st Panzer Division in reserve near Caen. His plan was to wait until the Allies were disorganized on the beaches, then hit them with a sledgehammer of armor. At around 4 p.m. on June 6, the 21st Panzer Division finally attacked. They drove north, aiming for the gap between Juno and Sword beaches. They expected to find light infantry. They expected to roll over them and reach the sea, splitting the Allied invasion in two. But instead of light infantry, they ran into a wall of steel. They ran into the DD Shermans and other tanks landed by LCTs that had already moved inland. The German Mark IV tanks rolled through the cornfields, confident. Suddenly, they were taking fire from 75mm guns and the dreaded British 17-pounder Firefly tanks. The German commanders were stunned. Where did these tanks come from? They radioed back to HQ. They don't have a port. The German attack stalled. They managed to reach the coast in one small sector, but they couldn't hold it. They were being hammered by Allied tanks on the ground and Allied aircraft in the sky. By evening, the 21st Panzer Division was forced to withdraw. The great German counterstroke had failed. It failed because the Allied beachhead was not a soft crust of infantry, it was a hardened shield of armor. The DD tanks had bought the Allies time. They held the line until the heavy follow-on forces could arrive. If the German panzers had attacked at noon and found only infantry, they might have driven the Allies back into the sea. But by 4 p.m., the funnies had already secured the perimeter. The German engineering logic, that tanks need ports, had been their undoing. They assumed they had a window of time to react. The swimming tanks slammed that window shut on their fingers. Today, a single DD Sherman sits near the beach at Juno in Normandy. It is a rusted, silent memorial. Another one, raised from the seabed off Salerno, sits in a museum in England. They look like normal tanks. The canvas screens are gone or folded away. But these machines represent one of the most audacious engineering feats of the war. General Percy Hobart, the man who was forced into retirement for his crazy ideas, was vindicated. His funnies, the swimming tanks, the flail tanks, the flamethrowers, saved countless thousands of Allied lives. Eisenhower later wrote that without Hobart's specialized armor, the invasion might have failed. The legacy of the DD tank is a lesson in innovation. It teaches us that in war, the impossible is just an engineering challenge waiting to be solved. The Germans lost because they trusted in static defenses and rigid logic. They built a wall. The Allies won because they trusted in adaptation and risk. They built a tank that could walk on water. The men who crewed these tanks were a special breed. They were soldiers who had to be sailors. They were men who locked themselves inside 30 tons of steel and drove into the ocean. Many of them lie at the bottom of the channel, entombed in their machines off Omaha Beach. But those who made it to the sand changed history. When the sun set on June 6, 1944, the Atlantic Wall was broken. And through the breach rolled the strange, ugly, magnificent tanks that had defied the laws of physics to liberate a continent. The laughter of the German engineers was gone, replaced by the roar of Sherman engines heading toward Berlin.